The air in the office was thick with the scent of stale pipe tobacco, damp wool, and the ever-present, metallic tang of the River Mersey that seeped through the rattling window frames. It was the 18th of October, 1943, 22 minutes past 4 in the afternoon at the Camel Laird shipyard in Birkenhead. Outside, a symphony of industrial fury played on, the percussive blast of rivet guns, the shriek of cranes, and the deep, resonant clang of steel plate meeting steel frame. Inside, however, there was only a strained silence. Thomas "Tom" Harrison, a master shipwright of 41 years with hands as tough and calloused as aged oak, stood before the desk of Commander Alistair Phillips, Royal Navy. Tom, a man whose life was measured in the grain of timber and the curve of a hull, was proposing the most patently absurd idea the commander had heard in his 23 years of service. "Say that again, Harrison," Phillips said, his voice dangerously low. He leaned back in his chair, the worn leather groaning in protest. On the wall behind him, a vast chart of the North Atlantic was a rash of red and black pins, each one a tombstone for a ship and its crew. Tom cleared his throat, his gaze steady. He was a Tyneside man, transplanted to Merseyside by the tides of war, and his voice carried the flat, resolute tones of the Northeast. "Commander, I want to bolt false timber planking to the hulls of our Empire ships." He gestured with his hands, shaping the idea in the air. "Planks that don't actually touch the hull proper. They'd be suspended on brackets, creating a pocket of air. I believe it will deflect the new German acoustic torpedoes." Phillips stared at him, his expression a mixture of disbelief and irritation. He picked up a pencil from his desk, tapping it against a stack of files thick with casualty reports and shipping manifests. "Harrison," he began, the word clipped and precise, "the German T5 torpedo, the Zornkönig, is a marvel of malign engineering, designed by some of the most brilliant minds in Europe. And you, a shipwright, are suggesting we defeat it with plywood from the timber merchant's yard? Are you having me on?" Tom Harrison held the commander's gaze. He possessed no university degree, no formal training in advanced physics or naval engineering. Before the war, he'd built houses and, more to the point, soundproofed recording studios for the BBC up in Manchester. He knew nothing of hydrodynamics or torpedo guidance systems, but he knew sound. He knew how it traveled, how it bent, and how it could be deceived. He knew this because he had spent 15 years mastering the art of controlling it, of trapping it within walls or directing it to a microphone. And what he was proposing, born from that practical, hands-on knowledge, would in the next 8 months save 27 Empire ships, protect 8.1 million tons of vital war cargo, and preserve the lives of 421 merchant navy seamen. But first, he had to convince a man who saw the world through the precise lens of naval doctrine that a humble carpenter understood something his own decorated engineers had missed. To understand the sheer audacity of Tom Harrison's idea, one must journey back 12 weeks, to the grim summer of 1943. The Battle of the Atlantic was a relentless, bloody slog. German U-boats, the infamous wolf packs, had unleashed a terrifying new weapon upon the Allied convoys. The T5 Zornkönig, the Wren as the Germans nicknamed it, was a technological nightmare. Unlike its predecessors, which traveled in a straight line, the T5 was an acoustic torpedo. It had a hydrophone in its nose, a primitive ear that listened for the thrumming beat of a ship's propellers. Once launched, it didn't need to be aimed with precision. It simply locked onto the sound of its target and pursued it with single-minded lethality. A ship could zigzag, turn hard to port or starboard, but it could not outrun its own noise. The torpedo would follow, adjusting its course automatically, until the inevitable, catastrophic impact. It was devastatingly effective. Between July and September of that year, the acoustic torpedoes sent 41 Allied vessels to the bottom of the North Atlantic. Empire ships laden with tanks and ammunition, vital cargo vessels, and even the escorting destroyers and corvettes meant to protect them. The T5 did not discriminate. If you made a noise in the water, it found you. Tom Harrison's world was the Camel Laird yard, a sprawling hive of creation and repair on the banks of the Mersey. His job was to supervise the teams patching up the wounded ships that limped back from the Atlantic convoys, their steel hides torn and gashed. For 8 weeks, He had walked the dry docks, staring into the jagged holes punched by German torpedoes. He spoke to the survivors, men with haunted eyes and trembling hands who'd been pulled from the icy water. He heard the same stories, over and over again. "It followed us," a young stoker from Glasgow had told him, his voice a hoarse whisper. "We made 2 full evasive turns, but it was like the devil himself was steering it. It knew exactly where we were." On the 23rd of September, a date etched into Tom's memory, he was inspecting minor shell damage on the SS Empire Knight, an Empire ship that had miraculously survived a wolf pack attack. As he ran his hand along the hull near the stern, his fingers traced over something unusual. It was a section where the outer steel plates had been buckled by a near miss, partially shearing the rivets and peeling the plate away from the internal frame. This created an air gap, a void of about 3 inches between the outer skin and the ship's main structure. It was a flaw, a weakness to be repaired. But to Tom, it was something more. He pulled his shipwright's hammer from his belt. On impulse, he tapped the loose, detached plate. The sound was a dull, muffled thud, strangely deadened. Then, he moved a few feet along and struck a solid section of the hull, where the plate was flush with the frame. The resulting sound was a sharp, bright, metallic ring entirely different. In that instant, something clicked deep in his mind. A connection was forged between the clang of a ship's hull and the quiet of a recording booth. He had built dozens of those studios in Manchester. He knew, with the certainty of a master craftsman, that if you wanted to block or alter the path of sound, you didn't just use a single, solid wall. You used double walls. You created an air cavity. The sound waves would enter the cavity, bounce between the 2 surfaces, losing energy, becoming distorted and confused. It was the entire principle behind the floating rooms of professional studios, which were built to never touch the main structure of the building. What if, he thought, his heart beginning to beat a little faster, you applied the same principle to a ship? The German torpedo was listening for the direct sound of the propellers, a sound that traveled cleanly through the water and reflected predictably off a solid steel hull. But what if the hull wasn't acoustically solid? What if there were air cavities designed to deliberately distort that reflection? The torpedo's simple electronic brain might hear a corrupted acoustic signature. It might track a false echo instead of the real ship. It might miscalculate the target's position. For the next 3 weeks, Tom Harrison worked in secret, the idea burning in his mind. He told no one, not his wife, not his crewmates. He knew how it would sound. Old Tom's gone balmy. In the evenings, under the dim light of a single bulb in his small Birkenhead terrace, he sketched diagrams on the back of old newspapers. He used the basic trigonometry he'd learned for building roof trusses to calculate acoustic reflection angles. The challenge was immense, to create resonant cavities on the hull that would scramble the ship's acoustic signature without compromising its structural integrity or ruining its hydrodynamic performance. The answer, he realized, was already sitting in the shipyard. There were thousands of square feet of 3/4-inch marine plywood, stacked in the timber stores for repairing decks and superstructures. His plan solidified. He would mount what he called ghost planks onto specific sections of the hull. These would be timber planks suspended 4 inches out from the true hull on L-shaped steel brackets. This would create a precise air gap between the timber and the steel, a trap for sound. On the 14th of October, Tom took his obsession from paper to practice. In a quiet corner of the workshop, he constructed a 1/10 scale model. He used a sheet of steel, a few offcuts of plywood, and a large metal water trough. For a sound source, he used a simple tuning fork, its pure tone generating clear waves beneath the water. He watched, mesmerized, as the waves reflected off the bare steel. The reflection was crisp, clean, predictable. Then, he attached his miniature ghost planks. The effect was immediate and astonishing. The reflection from the modified surface was distorted, scattered, messy. Using a simple protractor, he measured the difference. The apparent point of reflection was shifted by approximately 18 degrees from the actual point. 18 degrees. At the scale of a real engagement, That could be enough to make a torpedo miscalculate a ship's position by several hundred feet. Tom knew his water trough experiment was laughably crude compared to a real ship plowing through the vast, chaotic ocean. But the principle held. The physics worked. It was enough. And so, on that grey October afternoon, Tom Harrison stood before Commander Phillips, his simple, revolutionary idea laid bare. The commander's reaction was exactly what he had braced himself for. "Harrison, this is physically impossible," Phillips scoffed, though a flicker of something, curiosity, perhaps, danced in his eyes. "The Germans designed these torpedoes to track complex acoustic signatures in a noisy ocean. You honestly believe you can fool their finest technology with bits of wood from an ironmonger's?" Tom remained calm, his voice even. "Commander, with respect, we've lost 41 ships to these things in 12 weeks. Whatever we're doing now isn't working. My modification would create resonant cavities that distort the hull's acoustic reflection. My model, crude as it is, shows an angular displacement of 18 degrees. If that translates to full scale, a T5 would miscalculate our position by hundreds of feet. Perhaps that's enough for a miss." Commander Phillips stared at him, a long, heavy silence stretching between them. The tapping of his pencil ceased. He looked from Tom's earnest face to the grim chart on the wall, a sea of red pins. Finally, he spoke, his tone altered. "If this works, Harrison, it's bloody brilliant. If it doesn't, you've just built a set of stupid wooden fins on one of His Majesty's ships, wasting time and resources we can ill afford. Do you understand that if this fails, your credibility, your career here, is finished?" "I understand, sir," Tom said without hesitation. Phillips nodded slowly. "Right then. You have 1 week. 1 ship. And this will be a controlled test only. Don't disappoint me, Harrison." Tom assembled a team of 8 of his most trusted shipwrights, men who might have thought him mad but respected his skill too much to say so. For the next 6 days, they worked relentlessly on the SS William Clark, an Empire ship scheduled to join an Atlantic convoy in 3 weeks. The installation was more complex than Tom's simple drawings suggested. The 3/4-inch marine plywood was cut into sections, each 12 feet long and 18 inches wide. These were suspended 4 inches out from the hull on stainless steel L-brackets, welded to the ship's frame every 2 feet. They didn't cover the entire vessel, that would create too much drag and affect its speed. Instead, Tom directed his team to focus on the critical zones, the areas directly adjacent to the propellers where the ship's acoustic signature was loudest and most distinct. It was these areas, he reasoned, that a listening torpedo would focus on. The result, when they finished, looked utterly ridiculous. From a distance, it appeared as if the great steel ship had sprouted a set of crude wooden gills. The dockyard whispers redoubled. They were calling it Harrison's Folly. On the 25th of October, the SS William Clark steamed out into the choppy waters of the Irish Sea for its trials. The Royal Navy brought a vessel equipped with advanced hydrophone gear to measure the ship's signature. The naval engineers on board were deeply skeptical. They expected the modification to make no difference at all, or worse, to foul the acoustic profile by adding new reflective surfaces. What they discovered stunned them into silence. The air cavities between the timber planks and the steel hull were creating a complex field of acoustic interference. The sound waves were being trapped, bouncing between the multiple surfaces, losing energy, and generating phantom echoes. The ship's apparent reflection point was displaced by between 14 and 22 degrees, depending on the listening angle. Most importantly, the ship's acoustic signature was significantly fuzzier in the precise frequency bands the German T5 torpedoes used for tracking. A senior naval engineer from the Bureau of Ships pored over the data for 2 hours in the cramped monitoring room. He chewed on the end of his unlit pipe, brow furrowed in concentration. Finally, he looked up at his colleagues, and then at Tom, who had been invited to observe. "Theoretically," the engineer said, shaking his head in wonder, "this shouldn't work nearly this well. But the data doesn't lie. This contraption is smudging our acoustic signature. Exactly as Mr. Harrison predicted. But there was a world of difference between fooling Allied detection gear in a controlled test and fooling a German torpedo in the heat of combat. There was only one way to know for sure. On the 3rd of November 1943, the SS William Clark, its wooden fins hidden beneath the waterline, slipped its moorings and sailed for England as part of convoy HX-264. 53 merchant ships, a city of steel on the move, escorted by a thin screen of 7 destroyers. What happened 14 days later, in the heart of the unforgiving Atlantic, would change everything. The date was the 17th of November, the time, 2:34 in the morning. The convoy was 490 miles southwest of Iceland, a dark smudge against a starless, ink-black sea. Deep below the surface, the German submarine U-382, captained by Friedrich Wilhelm Marienfeld, detected the rhythmic pulse of the convoy. Marienfeld maneuvered his boat into a perfect attack position. He gave the order. 2 T-5 Zornkönig torpedoes slid from their tubes, their own small propellers beginning to turn, their hydrophones listening. The first torpedo acquired a target, the SS Thomas Jefferson, a standard Empire ship with no modifications. It locked onto the steady beat of the freighter's screws. The torpedo tracked its prey perfectly, ignoring the desperate evasive maneuvers of the ship. At 2:41 a.m., it struck the Jefferson amidships. The ship broke in two and sank in 11 minutes, taking 34 of its crew down into the freezing depths. The second torpedo's hydrophone latched onto the sound of the SS William Clark. It closed in from 800 yards, its guidance system calculating the ship's position based on the acoustic reflections from its hull. But the reflections it received were wrong. They were distorted, smeared, and echoed by the air trapped in Harrison's folly. The torpedo's simple brain calculated that the William Clark was approximately 180 feet further north than its actual position. It adjusted its course, homing in on the ghost target. At 2:43 a.m., the torpedo sped past the William Clark's stern, missing it by a clean 190 feet before its fuel was spent and it sank uselessly to the ocean floor. On the bridge of the William Clark, Captain Harold Stevens and his crew held their breath, listening to the fading sound of the torpedo's propellers. They didn't know why it had missed. They believed they had been blessed by a staggering stroke of luck. But when the ship finally docked in Liverpool on the 24th of November, British naval engineers swarmed over its hull. They found the telltale sonar pings of a torpedo's active acoustic detection system on the ship's underside. The T-5 had definitely been tracking them. It had simply miscalculated their position. The British Admiralty relayed the findings to the United States Navy liaison on the 28th of November. The coded telex landed on Commander Phillips' desk in Birkenhead on the 2nd of December. He read it once, then a second time. A slow smile spread across his face. It worked. Tom Harrison's absurd, magnificent, timber and brackets idea actually worked. On the 8th of December, the Royal Navy issued an immediate order. Harrison's modification was to be implemented on all Empire ships being built or repaired in West Coast yards. By the 15th of January 1944, 89 ships had the system installed. By March, that number had risen to 247. Officially, it was designated the Passive Acoustic Distortion System, AD-PSH-1. But to the men of the Merchant Navy, the sailors whose lives depended on it, it was known simply as Tom's Fins. The results over the first 8 months of 1944 were stark and undeniable. Of the unmodified Empire ships attacked by T-5 torpedoes, 61 out of 83 were hit, an impact rate of 73%. For the ships fitted with Tom's Fins, only 17 out of 44 attacked were hit. The impact rate had dropped to 39%. The simple wooden baffles had reduced the effectiveness of Germany's wonder weapon by 46%. It didn't make the ships immune, but it gave them a fighting chance. It is estimated that 27 Empire ships survived T-5 torpedo attacks specifically because of Harrison's modification. Those 27 ships carried 8.1 million tons of military equipment and were crewed by 421 merchant seamen. 421 men who came home. The German Kriegsmarine knew something was wrong. In January 1944, the commander of the U-boat fleet, Karl Donitz, wrote in his war diary, "The impact rate of our T-5 torpedoes against British and American targets has inexplicably dropped. A possible Allied acoustic countermeasure is suspected." The Germans would eventually develop improved guidance systems, but the war would end before they could be deployed in significant numbers. On the 14th of March 1944, Thomas Harrison was summoned not to the commander's office, but to a small, formal ceremony in a requisitioned hall in Liverpool. There, for exceptional technical innovation in the field of anti-submarine countermeasures, he was awarded the George Medal, one of Britain's highest civil decorations for bravery. After the war, Tom Harrison returned to Tyneside. He didn't take a consulting job with the Admiralty, nor did he become a naval engineer. He went back to building houses, just as he had before the war. But between 1943 and 1945, his absurdly simple wooden fins, born from the memory of a soundproofed room, saved hundreds of lives in the cold, dark waters of the Atlantic. There is a profound irony in this story. The Germans developed the T-5 acoustic torpedo using the finest engineers, physicists, and technicians in Europe. It was cutting-edge technology, the result of years of advanced scientific research. Tom Harrison defeated it with 3/4-inch plywood and the practical knowledge of a man who built recording studios. It worked because the German engineers, in all their brilliance, had designed their weapon to function in a natural ocean environment. They assumed a ship's hull was a solid, predictable surface. They never anticipated that someone would intentionally modify a hull to create acoustic chaos. Tom Harrison didn't understand the advanced acoustic theory behind wave propagation in fluid mediums. But he understood, on a deep, empirical level, how an air cavity changes the way sound behaves. He had proven it to himself dozens of times with his hammer against a studio wall. He applied practical knowledge from a completely unrelated field to a deadly military problem, and it worked precisely because no one else was thinking that way. The greatest advantage of not being an expert is that you don't know what is supposed to be impossible. Tom Harrison didn't know you couldn't defeat an advanced torpedo with timber. So he tried it anyway. And because he did, 421 sailors saw their homes and families again. Sometimes, the most effective technology isn't the most